Hey folks, these mics on? Can you hear us? Hey, thanks for having us. My name's Shaul.
I'm AlexRothacker.
We're going to show you how to hack databases today. Hopefully we're going to have some fun doing it. So, quick talk. We're going to talk first about the threat landscape. So I'll give you an idea for what's going on out there, what kind of attacks we're seeing, what kind of problems that are really hitting the databases in the world. Talk a little bit about database vulnerabilities. This mic kind of sounds a little rough, guys. We'll talk a little bit about database vulnerabilities. So I'll show you the kind of vulnerabilities that hackers can use to break into your databases. Then we'll exploit some of those vulnerabilities. So we'll go through, we'll slash and burn a little Oracle, we'll cut down some IBM DB2, and then we'll round it up with a few steps you can take on how to secure your own databases. So, Verizon does a great data breach research service. They're awesome. They go out, they investigate attacks, they do forensic investigation. They're probably the biggest and the best out there. They publish a report every year. You guys probably see it, the Verizon Data Breach Report. If you're not reading it every year, you should. It's really cool reading. And they talk about how many records have been stolen, how those records were stolen, where they were stolen from, what the attack vectors were. There's a lot of good information in there. They're tracking now back to 2004. So if you go back from 2004 on up, the data breaches that Verizon's investigated and they've been able to report on, you can count over 1 billion records that have been stolen in this 5 to 6 year period. It's a big number. 1 billion is a really big number. And if you think back to 2004, 2005 timeframe, there wasn't a huge amount of mega hacks that were happening then. A lot of it's been recent. In fact, in the last 120, 130 days, we've seen 4 massive hacks come down. You know, we've all heard about Sony. So first the Sony PlayStation network goes down, 77 million records get stolen out of Sony PlayStation network. Sony thinks they've contained the problem, and a week later they announced that Sony Online Entertainment has also been breached, another 25 million records. If you happen to live in Europe, they lost your credit card as well. It was in the clear if you lived in Europe. It was encrypted if you lived anywhere else. Pretty badass data breach. Epsilon. I saw a big Epsilon office on the ride over from the airport. Epsilon's a big email marketing company. They lost about 80 million records earlier this year when somebody was able to break in and steal 2-3% of their customer base and the emails that they send out. You probably all got some, hey, we lost your emails from some of the companies you do business with. I sure did. And Silverpop's really similar to Epsilon. Another email marketing company also got hit. About 20 million records stolen from them. It's just huge numbers recently of records getting taken out of systems. And those records are costing business a lot of money. There's an organization called the Ponemon Group that does research every year into the cost of a data breach. In 2010, it was $214 a record on average, which shot up to $330 when there was criminal activity involved. So you think about these numbers. Sony lost 100 million records, and it's going to cost, on average, between $200 and $300 a piece. Yeah, that's $30 billion. That's a lot more revenue than Sony does with their online entertainment and PlayStation network. Even if it only costs them $10 a record, that's all their revenue. That's pretty serious shit. So it's plain and simple. Organizations just aren't protecting themselves. 96% of breaches in 2009 and 2010 were avoidable through, quote, simple controls. 89% of organizations that had credit card breaches failed their last credit card data audit. 43% of attacks in 2010 involved script kiddie skills or less, so the ability to cut and paste. 100% of the attacks we're going to show you today involve script kiddie skills or less. We're big into the cut and paste. 92% of the attacks that Verizon looked at last year were not considered highly difficult. And when you dig into that, basically that means that you don't need to know how to write code in order to execute those attacks. So 92% of attacks, you don't need to know how to write code. I mean, you're talking about a pretty easy target out there. And then one of the bits that I think is really interesting is the insider attacks. And the insider attacks represent a kind of a small portion, but they tend to be painful. But most of those insider attacks are executed by non-technical employees, so it's not like the system administrator who's going in and turning bad and breaking into systems and stealing stuff. It tends to be the business guy that has access to some systems that's leveraging that business level access that they've got to steal data. So let's talk about database vulnerabilities. The kinds of vulnerabilities that hackers are going to use to break into databases are the same kind of vulnerabilities that you've been dealing with forever. Default accounts and passwords, weak passwords, patchable vulnerabilities, misconfigurations and excessive privileges, all of them can leave your database a mess. And it doesn't matter what database you're running, whether it's SQL Server, Sybase, IBM DB2, MySQL, Oracle, they've all got the classes of vulnerabilities. So user accounts and passwords. Oracle's probably got the biggest problem here because they ship the most default accounts in their database, some 30 some odd default accounts that ship in an Oracle database. Some of the ones that I like, the account system, which is a DBA account in the database, it's got the password manager. The account sys, which is the most powerful account in Oracle, it's sort of the root account of Oracle, it's got the password change on install. Now when you install an Oracle database, the first thing you have to do is log in as sys. So you type sys, change on install as the password. You'd think that people would change the password when they've typed change on install for the password. I can't tell you how many production Oracle databases I've walked up to and logged in as sys with the password change on install. I mean, it's ridiculous, and I like that password a lot. DBSNMP. DBSNMP is the account Oracle uses for their Oracle Enterprise Manager to manage all their databases. It's kind of a cool central management tool. Password's DBSNMP. Almost everybody uses the feature, so almost everybody's got DBSNMP turned on in their database. Almost everybody's got the password set to DBSNMP. And if I can log into your database with DBSNMP, I'm not a DBA, but I'm one step from being there. It's pretty simple to get there. The other databases have similar issues. MySQL used to ship a root account with a blank password. SQL Server and Sybase have a system admin or SA account. The default password there is also blank. These days with SQL Server, when you install it, you actually have to check a box to keep that default blank password. People check the box. DB2's got default passwords. They're all over the place. And at the same time, you've got users assigning their own passwords, right? And people pick password 123 or admin 123 or whatever you like as your password, and they're easy to guess. And there are tools out there that are readily available that are hack database passwords for you. You know, every password cracking tool that you've ever looked at probably has a database module right now. So you can find database modules for Loftcrack, for Cain Enable, you name it. Plus there's a ton of database-specific password crackers out there that'll go out and guess passwords for you. And almost nobody's actually watching for failed logins on their database. So you can pretty much guess passwords all day, and nobody's going to notice, at least not until you break in and steal their data. Missing patches. So missing patches are bringing us the privilege escalation vulnerabilities that allow users to become DBA or equivalent. They're bringing us the buffer overflows that allow us to load and run our own code on the database servers. They're bringing us the denial of service vulnerabilities that allow us to knock databases right off the network and stop business from running. And then we've got misconfigurations. Databases are so complicated, easily as complicated as any operating system. So many settings, so many configurations, so many options to make mistakes. And the database vendors don't make it any easier on you. They ship you an insecure database by default, so you got to go and change the configuration in order to make it secure. So Oracle does stuff like give you permissions on the UTL file. It's a utility that allows you to read and write operating system files through the database. They grant it to public, which means everybody in the database has the right to read and write the operating system through the database. Why? Why would you grant that? Well, if you look at Oracle's docs, their security docs, they say the first thing you should do is revoke that privilege. Well, why is it there in the install? The best part of this little privilege is that, well, when you patch your Oracle database, you apply one of the security patches that they roll out every quarter, they add those privileges back to public. So if you've gone through and followed their documentation and taken everyone's privileges away to read and write the operating system, and then you apply a security patch because Oracle just released a ridiculous vulnerability that's remotely exploitable without authentication, you've just created another hole in the process. Good stuff. And it's not just Oracle. I like to pick on Oracle because they tend to have a lot of customers and a lot of high-value data in their databases. But we can tear apart SQL Server, Sybase, DB2 just the same. They've all got similar issues, similar default configurations. This function called XP Command Shell that exists on SQL Server and Sybase lets me run operating system commands through the database as the database software account, which is very often an admin account in the OS. You can imagine how painful it is when anybody in the database can access the OS as an administrator as a default database configuration. Again, 96% of breaches avoidable through simple controls. This is the kind of simple controls we're talking about. So let's hack some databases. First attack. We're going to take over the operating system that this database runs on. We're going to attack Oracle 11g. This is 11g release 1. This is a pretty widely deployed database platform. This attack requires create session privilege. So that means the ability to log into the database. So when the attack gets started, you'll see Alex will get the attack started by building a new user and giving him the minimal privileges just to log into the database. In the end, we're going to gain complete operating system control, and from there it's trivial to gain complete control of the database. And we're going to do it by exploiting a command injection vulnerability in a function where Oracle effectively allows users to set their own privileges to load and run Java code on the database. This was patched in April 2010, so about a year ago. If you're running industry average, you're just about to apply this patch to your systems. Alex, please hack Oracle.
Okay, so here you see we have a login to our Linux OS, and just to show you, basically, we're looking for this file here, temp oracle dbms jvmx perms proof of concept, right? And the file isn't there, which is kind of what we expected. We log into our Oracle using SQL+, and we create a new user, identify by pass, right? And we grant create session to the user, which is really like this super basic privilege that you need in an Oracle database. Pretty much everybody gets that. We connect with our password, right? Really straightforward stuff. And we look, like which users have the all files privilege, and nobody has it. We go, and here you can see we run touch on this file, right? Through our Java wrapper. And again, we'll see we've got an error message, and this fails, which this is all what we expect, right? This is how it should work. Now we go and we create this policy that basically grants all files, right? And create a little cursor. And here is where the exploit happens. It's the import JVMS perms. So this is basically the vulnerable procedure in Oracle. And it allows us to import, even though we are only public, we can import these permissions. And suddenly, we do these same things, right, that we just did before. And look, we have the rights to all files, full OS access through Java. We do the same thing again. We run our touch command. It succeeds. We disconnect from the database. We do our ls. And look, the file is there. So as a very simple Oracle user, we just ran an OS command, which we were really not supposed to do. This exploit was found by David Lichtfield and presented at Black Hat in early 2010, actually before Oracle had patched it, because they were kind of like behind it, and I think he was really trying to prove a point there and get them to patch this.
So there's a bit of database code up there, and maybe you're like me and you're not a DBA and you didn't understand that database code. What we just saw was the results of a little bit of cut and paste. So if you go to Google and you type DBMS JVM Xperm